Hi guys, this is Mr. Urrego, and today we're graphing exponential functions. We're going to learn how to graph exponential functions. We have several examples, including these two beautiful things. First of all, these are three exponential functions. My first one, the red one, is equal to 2 to the x power. The blue one is 4 to the x power. And the green one is 9 to the x power. So if you notice, the base is changing. The base in the first one was 2, this one is 4, and this one is 9. As my base increases, it gets steeper. 4 to the x is steeper, 9 to the x is really steep. And on the bottom, near the 0, is going to get flatter. Okay, so those are exponential. As my base increases, the steepness of the line increases. Let's talk about this one first. Here's my exponential. AB to the x. B is going to be my base. A is a constant, which is also your initial value. X is my exponent. That's why it's called an exponential, because my exponent is the variable. A couple things that we need to be aware of. The A has to be different from 0, because if this is 0, the whole thing cancels. B, my base, has to be different from 1. Okay, all the time, because if it's equal to 1, then it's going to be a constant. It's going to be a horizontal line. Now, when the b is greater than 1, then this is going to turn into an increasing function. When the b is between 0 and 1, then it's decreasing, and I'll have something going down, decreasing. The smaller the value, the steeper the line. So let's pretend that this is, I don't know, 1/2 to the x power. So if I graph 1/6 to the x power, this is smaller than this, therefore my graph, it will be steeper. In the other way, when it's greater than 1, let's pretend this is 2 to the x power. The bigger, the steeper. All right? This will be like 9 to the x power. I hope you get the idea. Now let's graph. To graph this, and our original function is, let's create a table of values. -2, -1, 0, 1, and 2. Okay? We plug it in here. So this is going to be 2 to the -2, and the value is going to be here. 2 to the -1st, 2 to the 0, 2 to the 1st, and 2 to the 2nd. 2 to the 2nd, 4. 2 to the 1st, 2 to the 0, anything to the 0 power is 1. Now, if I have a fraction, 2 to the -1, to turn that exponent into a positive exponent, you bring it down. 2 to the -1 is going to turn into 1 over 2 to the 1st, which is 1/2. Same idea. 2 to the -2 is going to become 2 to the 2nd power on the denominator, which is 1/4. Once I have these values, my table values, I'll just plot them. -2, 1/4. -1, 1/2, 0, 1. 1 is 2, and now we can see the increasing, and 2 is going to give me 4. You see how it's going to go there? Okay, one more thing. An exponential function has an asymptote, and my asymptote is here. It's going to be any vertical movement, okay? Because there's nothing there, then my asymptote is 0. So my asymptote is the line y equals 0. Okay, y equals 0 is this asymptote, is the horizontal asymptote, y equals 0. Now let's connect the points with the curve. Start with the asymptote, connect. And that's my original function. This is the parent function, f of x equals to 2x. Let's talk about domain. My domain. Arrow to the left, arrow to the right, meaning from -infinity to +infinity. The range. We look at the y values, right? I have an asymptote at 0, therefore my graph is not going to go below this. So my range is from 0, arrow to the top, meaning it's going to go to infinity. 0, the asymptote is not being touched, therefore it's not included, so my 0 is not included. Alright? And right now it has a y-intercept, which is 1, 0. Okay, now let's talk about some transformations. Alright, the first transformation is going to be when the x is negative. So what I did is I brought back, this is my parent function, I brought the table of values, and the only thing that I need to do is to realize that when my x is negative, that means it's going to be a reflection over the y-axis. reflection over the y-axis. That means this graph is going to go to the other side. So if this is the y-axis, every point will use this line as the line of symmetry. So if this point is 2 away from the axis, then I'm going to go to the other side 2 away, and that's my new point. This point is 1 step away from the y-axis, therefore 1 away in the other side. This is on the y-axis, and now let's go to the other side. This is on the left, therefore reflection is going to go to the right, left 2 steps, and my asymptote is the same, which is y equals 0, and that's your horizontal asymptote. Once I have these points, you know this is a curve, and once you reach the asymptote, you're going to go like really close to the asymptote, but will never touch. Okay? And that's my reflection over the y-axis, which is this function. Now instead of the x being negative, now is the whole function being negative. Therefore, this is the y. When this happens, it's a reflection over the x-axis, meaning this graph is going to go to the other side. And the x-axis is the line of symmetry. Let's start from the line of symmetry. This is 1 away. This is 1, 2 away, so 1, 2 away on the bottom. And this is 4 away, so I go 4 away in the bottom. And now look at my line. So when the negative is in front of the function, it's a reflection of the x-axis, and this is what happens. What about I have both? Okay, so let me explain. Let me go back to the previous two. When there's a reflection of the y-axis, all right, look what the values are changing. Let's get the values for this point. This is 2, 4. It's being reflected over the y-axis. Therefore, this point turns into -2, 4. So when there's a reflection over the y-axis, my x value changes. Every single x value, this is 1 and now it's -1. Every single x value, this is 1, 2, and now it's going to be -1, 2. Every single x value is changing. And that's when I have the x negative. The x values are changing the sign. When it's a reflection over the x-axis, what's the value that's changing? Let's take this value again. This is 2, 4. But now it's been reflected, and this is 2, -4. So now is the y value the one that is being changed, right? And that'll happen to every single one of them. 1, 2 became 1, -2. As you notice, the y values are being changed the sign. Okay, so this is a reflection over the x-axis. If I have both, that means the x signs and the y's will change. So all these signs will change because this is a reflection, right? Remember, this is a reflection over x-axis and this is a reflection over the y-axis. So both will change. So this -2 turns into 2, 1, 0, -1, -2. All of them will change the sign, and all of these that are positive will turn negative. And now if I plot these values, it will give me a reflection of this line over the x and y. Okay, and what that means is when there's a reflection over the x and the y-axis, meaning there's symmetry among the origin. Okay, and you'll see that in a minute. There's going to be symmetry among the origin. First point is 2, -1/4, 1, -1/2, 0, -1, and I hope you see that is the movement. -1 is -2, and -2 is going to give me -4. So look, my graph, asymptote, and that's this graph now. Okay, so those are the basic transformations when there's a reflection over the x, the y, or both. In this case, because there's a both, it's going to be symmetry among the origin. So technically it's like a 180-degree flip, rotation. Okay, this will come this, and this top will come this, like an 180-degree rotation. Now let's practice. So now we're going to graph this using a shortcut. If you notice, I like to create a table of values and I like to have at least 5 values. But technically, if I have at least 3 points, I'm able to tell how my graph is going to look like. So I'm going to use 3 points, right? So basically, I want to know how is my graph around the origin, especially here when it goes exponential, when it starts increasing really, really fast. So I want to know when the 0, 1, and 2, 0, 1, and 2, right? I want those values. I'm going to use that over here. So what happens is the following. Where's the shortcut? Okay, the shortcut means I want 0, 1, and 2 in here. But because the x is going to change and I'll have a negative here, I can have many things in here at that exponent. Anything that is with the x, I'll make it a 0, I'll make it 1, and I'll make it 2. And from here I find the values of x. So here from the x is minus 1, so x will be negative 1. And this is the value that I'll put on my table of values. Minus 1, x will become 0, and that's what I'm going to put on the table of values. And here minus 1, which is going to give me 1, and that's in my table of values. So that's just to make sure that I have values around my origin. Once I have this, I got to go back and plug it in. First value is negative 1, 2, negative 1 plus 1 minus 2. Remember, this is your horizontal asymptote, negative 2. So at negative 2, I have a horizontal asymptote. Excellent. Let's plug it in. Negative 1 plus 1 is 0. 2 to the 0 minus 2. 2 to the 0 is 1. Minus 2 is negative 1. 2 to the 0 plus 1 minus 2. I'm placing the x by 0. 0 plus 1. 2 to the first. 2 minus 2. And I'll do the same with the 1. 2 to the 1 plus 1 minus 2. 1 plus 1 is 2. 2 squared is 4. 4 minus 2 is 2. And I have these points now. Let's plot them. Negative 1, negative 1. 0, 0. 1 and 2. And here it's going to start increasing. So as you notice, my graph is coming from here. So asymptote, points, and here we go. Now, a couple questions that we're going to ask you. Domain. Arrow to the left comes from negative infinity. Arrow to the right, positive infinity. My range, up and down, right? This is an asymptote, meaning my graph is not going to touch that negative 2. So my range will start at this value all the way to infinity. Okay, y-intercept you have right now, that can ask you also. Y-intercept in this case is 0, 0. It's not necessary anyway, but domain and range is the main thing. Oh, hold on. Horizontal asymptote. All right, so my horizontal asymptote, HA, is equal to y equals to negative 2. The equation of my horizontal asymptote is y equals the value. Let's try another one. Here, x and y, 3 values. Whatever I have here, I'll make it equal to 0, to 1, and to 2. Whatever I have with the x, negative x, negative x, negative x. From there, divided by negative 1, x is 0, and that comes over here. Divided by negative 1 divided by negative 1 is negative 1. Same idea, divided by negative 1 is going to negative 2. And then I plug these values into my original function. 2 to the 0, to the negative 0, minus 3. 2 to the negative 0 is going to become anything to the 0 is 1. Minus 3, negative 2, and that's my first value. Negative 1. 2 to the, this is a minus, but the x is also negative 1. So those two negatives become positive 1. 2 to the first is 2, minus 3 is negative 1. Same idea with the last value. 2 to the negative 2, minus 3, 2 negatives becomes positive. 2 squared is 4, minus 3 is 1. I have these values, let's plot them. 0, negative 2. Oh, hold on. Horizontal asymptote. y equals -3. We need to graph that horizontal asymptote. And we have one of the values. Next, 0, -2, right there. -1, -1. -2, 1. And as you notice, my graph has a transformation. And here's going to go up next to the asymptote. It has a transformation because the x is negative is a reflection over the y-axis. Let's work on this one. Now this is between 0 and 1. Okay, meaning it's going to be a decreasing function. X and y. There's nothing with the x, so technically I can just do my table of values. -2, -1, 0, 1, and 2. As many points as you want. Guys, the whole idea is to understand. First one is going to be 1/2 to a -2. Okay, what happens when I have a negative exponent? The negative exponent is going to make the numerator goes down and the denominator goes up. To get rid of that negative exponent, I flip the fraction on the inside. And then my exponent becomes positive. And 2 squared is 4. Let's do it again. 1/2 to a -1. Flip the fraction on the inside. And instead of the negative, it's positive. 2 over 1 is 2. To the first power is 2. Anything to the 0 power is 1. 1/2 to the first power, 1/2. 1/2 to the second power. 1 squared is 1. 2 squared is 4. And I have these points now. Okay? Let's plot them. -2, 4. -2, 1, 2, 3, 4. -1, 2. 0, 1. 1, 1/2. 1, 1/4. And what's my horizontal asymptote? Any value that comes after that. In this case, 0. So my horizontal asymptote is y equals 0. And let's graph my horizontal asymptote. That's my horizontal asymptote. And this is a decreasing function because the value of my base is between 0 and 1. There we go. As you notice, I'm giving you all type of examples. Let's work on an exponential now. Now e is just a number. E is the same as 2.718 and so many more decimals. We're going to round it to 2.7. Okay, guys, if you're here with me, please like the video, subscribe to the channel, comment, okay? Comment. All right, let's go. So e to the x is the same thing. Our calculators have an e included on the calculator. Let's go to Google calculator, the most basic calculator. Look at that. E equal. Oh, come on. E. Oh, there you go. 2.718. You see that? So e is a number. It's like the same as pi. This is an irrational number. So don't get confused because you see the e. E is the same process. So I'm going to graph e the same way that I did with the other ones, creating a table of values. Do I need a lot of points? Not really. I can choose to do 2 or 3 points. I'm going to use 0, 1, and 2. E to the 0 is 1. E to the first power is 2.7. E to the second power, 7.4. Where's my asymptote? Right? That's my horizontal asymptote, which is y equals 0. And there's nothing next to it. Horizontal asymptote is point 0.01, 1, 2.7, 2, 7.4, something like that. As you can see, it grows really, really fast. Increasing function, connect. That's E. All right, my domain, all real. From -infinity all the way to +infinity. My range, from 0 to infinity. I hope by now we understand this. Let's play around with another one. We had this, kind of complicated. We're going to use the same trick that we did before. We want 0, 1, and 2. If you want more points, make them. That doesn't matter. X plus 2, x plus 2, x plus 2, whatever you have with the x. From here, x is -2. right? You subtract 2 on both sides. Therefore, my table value is going to give me -2. From here, -2 minus 2. 1 minus 2 is -1. And from here, -2 minus 2 is going to become 0, right? And these are my 3 values. Now I plug this back. When the x is -2, I have -x, -2 plus 2 minus 3. -2 plus 2 is 0. E to the 0. E to the 0 is 1. Minus 3, -4. Let's go. When is -1? E -1 plus 2. -1 plus 2. E to the first is -2.7, right? And this minus this is -5.7. Next, 0. 0 plus 2. 0 plus 2 is e to the second power. E to the second power is approximately -7.4. Minus 3 gives me -10.4. Plot these values. Remember, what's my horizontal asymptote? Y equals -3. -3 horizontal asymptote. You gotta graph that one. -2, -4. -2, -4. Oh, this is gonna be underneath. Excellent. -1, -5.7. -1, -5.7. 0 is -10.4. It's all the way down here, right? So that means my graph comes from here. Smooth curve, smooth curve, smooth curve. Okay, excellent. Domain, arrow on the left, arrow on the right. -infinity to +infinity. Range, oh, in this case, it starts at -infinity, right? Because I have an arrow going down. And it goes all the way up to -3. Parentheses. And we're done. Alright guys, don't forget to subscribe, like the video, comment please. Help me out get into the algorithm for YouTube. Have a beautiful day. Make sure you check this video that's going to help you out with logarithmic functions, how to graph them. Alright? Take care. I'll see you next one. Bye bye.